Hello everybody, I'm hoping that you're having a good day, good chaos engineering day at GOTOpia. Looks like a lot of good stuff going on. Thank you for coming to my talk. My name is Miko Pawlikowski, everybody calls me Miko, so Miko is fine. I am the author of the chaos engineering book from money. Chaos engineering, site reliability through controlled disruption, and I'm also a software engineering lead at Bloomberg, working mainly with Kubernetes. My plan for the next 20 minutes is to really bore you. I'm going to argue that making chaos engineering boring is a good thing. I'm going to try to convince you that you should be thinking that too. And I'm going to give you some tools on how to achieve your own, boring situation in your own adoption path. So if that sounds interesting to you, let's go for it. Here's the plan of the talk. I'm going to start by defining chaos engineering because we all need to be on the same page, and I like to describe, what it means when I'm saying it. And then I'm going to talk about the innovation adoption lifecycle curve, where we are on it, what it is, the kind of thing that you typically see in articles about smartphone adoption or wearables or tablets or whatnot, the new technology. And then I'm going to talk about why boring is good, at least why I think boring is good and why we need it with chaos engineering. And in order to achieve boring, we're going to talk about the chaos engineering myths that just refuse to die and about getting chaos engineering on the roadmap. And I'm also going to plug in my book. So if that sounds like a plan, let's get started with the obvious thing. And this is the definition of chaos engineering, principlesofchaos.org. And it goes like this. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And that's great. That's a little bit of a mouthful, but if you remove the fluff, it looks something like this. It's experimenting to build confidence to withstand turbulent conditions. And this is basically what I mean when I'm talking about chaos engineering. There's, notice there's nothing about chaos monkeys or having to do it in production. It's just the experimentation on a system to build confidence that it's going to behave the way that you think it should in presence of turbulent conditions. Okay, and this is a new thing. A few years back when I started talking about that, people were pretty surprised. I've always had the same response that, oh yeah, this sounds risky, this sounds unusual, I can't potentially do that. And any new technology, it finds itself somewhere on the innovation adoption lifecycle. This is a bell curve with a distribution, and as you can see, it's cut in pieces. You have the, the standard deviation, 1 and 2 to the left and 1 to the right. And this is where, every piece of technology finds itself and has to crawl from the left to the right to become mainstream. And, when you think about it today, a smartphone is a pretty unremarkable thing. You can get one on a chip and it's remarkably good. It wasn't like that at the beginning. If you had the pleasure of working with one of the early Android phones, you might remember that it was not a particularly pleasant experience at the beginning. And then, through the adoption and through the growing popularity, things kept getting better and better and better. And now you can buy a really cheap phone that's going to last a day, that has a really nice screen. You can install plenty of different apps on it. And this is all things that we take for granted now, right? This is just something, part of the landscape right now, which means that it's boring, right? It's mainstream. There's nothing exciting about it anymore. Now we're looking for, foldables and whatnot and all kinds of things to try to make it a bit more exciting. But the fact that it was boring means that people, it's part of people's lives. Everybody has one. Same with flying an airplane. If you were around back in the day, I suspect that it must have been pretty thrilling, first commercial flights and everything. Today, you just jump on that train, you don't think about, on that plane, you don't think about it at all. You just expect to be safely delivered to your destination. And it's only when planes do go down on occasion, very, very, very small fraction of the time, that people start paying attention. And that's news. No, I've never seen on BBC people go and say, oh, another plane landed. That's amazing. And this is what chaos engineering needs to do to become part of the landscape of every engineering team out there. It needs to become boring. right? So going back to the curve, it looks like this. You have the innovators, the first small fraction of people who actually see enough value in it that they're ready to put up with whatever, shortcomings of the early technology are, and they always are. Then you have the early adoption, early adopters, a slightly bigger group who are still able to put up with these things, but it's slowly, growing in the popularity. Then the early majority on the left side of the peak, late majority on the right side of the peaks, and then the people who are a little bit late to the party, like, that uncle who's still using a brick phone in 2021. But in order to get chaos engineering, and probably if I was to estimate, I think it would be early, where chaos engineering is right now. I think it would be either on the late part of the early adopters or early part of the early majority. But we want to get it over that peak. We want to get it all over to the right side. And how do we achieve that? Well, first thing we need to do is address some of the myths that just keep being a problem. Actually, I did a little poll on LinkedIn here, and I asked people, hey, so what's the biggest thing that's blocking you from doing chaos engineering? As you can see, over 50% got difficulty generating buy-in. And from the comments that followed, a lot of people brought up the different myths, the different things that the internet thinks about chaos engineering. And this is like a sample. This is the kinds of things that I typically see and hear basically all the time, right? As I speak about chaos engineering. You hear a variant of, oh yeah, it's Chaos Monkey, right? And this one is tricky to kind of address because, yeah, it is kind of about Chaos Monkey. Initially, it was about Chaos Monkey. We kind of all started with Chaos Monkey at Netflix a few years ago. But it's about so much more now, right? The way that I see it is that the Chaos Monkey represents one side of the spectrum. It's the side of the spectrum where you want to get started and you want to do something easy. And Chaos Monkey is easy. You release that and it goes and does things randomly. It looks at your VMs, takes them up, takes them down, and it can find things for you. So this is kind of like the easy side of the spectrum where you make no or very few assumptions about the system. Honestly, you might not even know that system that well, not in the detail. And you can already get the value just from randomly doing things. It's kind of like a little bit like the practice of fuzzing, when you generate all these random inputs and, this combinations and you see what happens. Kind of like another layer of testing. And it also works really nicely with what we call the emergent properties. And emergent properties are basically the properties of the system or, the properties of an entity that you didn't realize were there or emerge from interactions between the subcomponents of that thing. This is a really nice, really cheap way to potentially find problems like that. But it's just one side of the spectrum. The other side of the spectrum is when you know a lot about the system. And you can, from the theory, come and point, okay, this is probably going to be a weak bit of the system. Let's see that it withstands this particular problem or that particular failure. And the practice of chaos engineering kind of, has both of the sides of the spectrum that are for your usage and anywhere in between, right? You can start with just randomness, or you can go and design very sophisticated, very tailored experiments that test a particular property of a system, if you know about that. So that's the first myth. The second myth is the evergreen, it's testing in production. And this one is probably never going to die because, a lot of the early stuff was about, how we do it in production. And yes, that is great. Like, the holy grail is to be so confident in all of that, we've done so much testing in the previous stages and everything that now you think that you are ready to do it in the production environment. And that's great. If you can do that, that's amazing. But there's always going to be the cases where it's just not acceptable. If people die, if you find a problem, you probably don't want to do that, right? Or if you lose plenty of money or you're contractually, legally obliged to do something, you don't want to do it, right? You don't want to take that risk. So the production element is always funny because, we want to get there, and at the same time there are situations when we'll never be able to do it. But by no means does chaos engineering mean that it has to be in production. It's nice, it's great if you can, but you can get plenty of value from the earlier stages and different versions of testing, so there is no reason to limit yourself to that. Okay, another one that I hear often is some kind of version, but it's only for X, only for massively distributed system, or only for this technology, or only if we're in the cloud. And that's probably because, Netflix is big and they have the massive cloud deployment, and so people assume that their little system or their little situation might not be applicable for chaos engineering, and it's wrong. And it's one of the things that I really try to kind of underline in my book, is that regardless of the system, whether it's big, small, green, yellow, Java, Golang, whatever it is, you can apply the same principles and the mindset to experiment on that to increase your likelihood in surviving the difficult situations. So I'll plug the book at the end, but it's really important to understand it's not just for the big guys doing Netflix and Google whatnot. It's for everybody, and there's really no reason for you to get some of that by IO. Another thing is that I also hear a lot, our organization is not mature enough for for chaos engineering quite yet, kind of speech. And I kind of understand where it's coming from. If you're not particularly confident in your system to begin with, and you don't necessarily have the test covers that you would like, and you know that there are some problems, but you're not quite sure about them, you might not want to go and do chaos engineering because you're just scared that it's actually going to break. You're not at that level of maturity, and people say that, and like I said, I kind of understand where it's coming from, but it's also a false kind of assumption, because chaos engineering is just a testing practice, that works on a different level. We work on a level of the entire system and introduce failure, and it's kind of like end-to-end testing for the unhappy paths, for the sad paths. So, all of the other kind of layers of testing, they're still applicable, but even if you're not super confident in them, there's nothing that prevents you from experimenting a little bit, setting up a little experiment and seeing that the system as a whole behaves the way that you want it to. So the maturity helps, and especially with like observability tools that actually allow you to see what's happening with your system. That might be a little bit of a hurdle, but there's really nothing that prevents you from doing chaos engineering, even at the earlier stages of maturity. There's also kind of like a similar connector to that, we already have chaos, we don't want more chaos kind of thing. And once again, it's usually, kind of like half joke, half not, gets a few greens, and it's great. But in practice, that just really shows that you don't fully understand what chaos engineering is about, because it's not about increasing the amount of chaos and unknowns, uncontrollable in your system. It's about the exact opposite. It's about decreasing the amount. And you don't inject random chaos unless you're just doing chaos monkey, just throw it at it and you don't look at it and you go home. Then maybe. The chaos engineering that we now talk about is much more scientific than that. You want to very tightly control the amount of the type and amount of failure that you inject into it to decrease the chaos, to decrease the uncertainty and the unknowns of the system by verifying experimentally what happens when that failure appears. So kind of once again, we already have enough chaos, wink wink. It just shows that you don't fully understand what it's about, because if you did, you would understand that this practice is about decreasing the amount of chaos. And the last one is kind of like a variant of the chaos monkey. Oh yeah, it's about breaking things randomly. I kind of addressed that with the first one, but it keeps popping. So once again, yes, the randomness is great. It can work like fuzzing for the entire system, but then there's more to that. And there's the entire, scientific framework that goes with it that makes it more applicable. Okay, so these are, the kind of myths that I keep hearing. There's probably another one, which is basically the name, right? It's kind of late now to to change that because we all went with the chaos engineering, but it would probably be easier sell if it just wasn't called, I know some people who call it like resilience engineering to make it a bit more palatable to whoever they're selling it to. But honestly, it's probably a bit too late to do that. The other thing that people were complaining about was the inadequate training, and we're trying to address that. You guys are obviously ahead of the curve here. I came to the Chaos Engineering Day, so you are interested in the right stuff. But it's true that, it's still a little bit early days and there isn't as much material that you can use and the training options are limited. But, we're trying to address that, so watch that space. Once you've kind of tackled these hurdles, you're still left with, the kind of wrestling that happens before you can actually put the Chaos Engineering on the roadmap. And for this one, I just wanted to give you like two main tools, right? And it's the risk and reward that applies more to your managerial part of your team, and then getting code less that speaks volumes to the actual engineers who do the day two operations, who are responsible for the platforms and the software when it breaks. So maybe I'll start with latter because this was kind of like a more straightforward sell. Everything that makes, I don't know how many of you actually, are being called when things break at work, but I think we can all kind of, be empathetic about that. You don't want to do that. It's horrible. You have to wake up, you have to context switch, you have to log in, you have to see what's actually going on. A lot of the time, it's not going to be anything that interesting, and if you could just do something to minimize that, decrease the rate at which it happens, or if you could potentially simulate things, during working hours, so that if it has to break, it's gonna break when everybody's here, and we can fix it quickly. Wouldn't that be amazing, right? Well, it would, right? And this is what Chaos Engineering is about in a big part of it. So this sales pitch is typically much easier. It's typically a fairly good thing. It's like, oh yeah, well, if we do that, I'm going to be called less, so let's do that, right? The other thing is about the risk and reward for the managers, the people who have to okay you going out and saying that. And to kind of illustrate that, I have a shark for you. It's a nice shark. There are credits for that photo later in the slides if you want one too. And this is kind of like what I call the shark and hamburger paradox, because if you think about that, if you stop a random person in the street and you ask them, hey, how likely are you to die of a shark attack? They're probably going to very, very grossly overestimate the likelihood of that. My Googling skills told me that in 2020, the country that has the most fatal shark attacks in the world, the US of A, actually had the grand total of 3 of them. Meaning that the likelihood of dying from a shark attack is nowhere near the likelihood of dying from, for example, the heart disease, the #1 killer. That's the data for the US once again. So just because people watch some movies and, they saw scary sharks ranging from the Jaws to the Meg, they're going to grossly overestimate the danger of that. And this is probably, because these images speak to people and because, we might be evolutionarily linked to be afraid of that. But you really should be more afraid of that hamburger that you're about to eat, because it's going to increase your risk of heart disease. And this is the thing that's likely to kill you. So this kind of applies the same way to Chaos Engineering. When you take a moment and sit down and actually evaluate the risks, and you do some very basic, back of the napkin kind of mathematics, you'll see that there isn't anything to be, that the ratio of risk to the reward might be much different from what you would think just by the name of that. So, the chaos in the Chaos Engineering is kind of like the teeth on that shark, makes it scary. But if you actually compare apples to apples and look at some numbers, you'll see that there isn't much to be afraid of. Okay, and so this is the conversation that you kind of need to be prepared to have with whoever is okay introduction of things like that on your team. But once again, just take a napkin, take a few minutes to think that through, and just don't think about the name too much. Okay, so I'm slowly running out of time, so probably time to plug my book. This is the book, looks like that. It's from Manning. If you would like a discount, there's a 35% discount on the slide here. That should be available for next month or two. And if you are interested in a book that talks more about the practical aspect of chaos engineering, unlike the other books that were already available when I wrote this one about the theory, this one is all about the tools and the methodology and the application. So, like I mentioned before, it tries to show you an entire range of different levels in the stack and applications and technologies and frameworks, languages, whatnot, to show you how applicable it is. And it takes, things from starting from like a single binary legacy that you're not even looking into a source code of, and you can tamper with it by blocking system calls and verifying that the retry logic is behaving the way that you think it would behave, through things like Docker, understanding, on the all the other underlying Linux kernel features that are leveraged to implement the containers, implementing your own little container, and in general experimenting on containerized applications, all the way to things like Kubernetes and testing both applications running on Kubernetes as well as Kubernetes itself, if you happen to be responsible for running Kubernetes clusters, and then everything in between, from building chaos engineering into an application, working with JVM, injecting bytecode on the fly to verify your error handling logic, all the way up to working with JavaScript in the browser and injecting failure into the UIs that you might be running to verify it works, the way that you want it to. So this is really a very practical book, and if you would like to talk about that, the best way to connect with me is through LinkedIn. Hopefully that QR code gets you there. So if you have any complaints about the book, you know where to send them. And finally, this is where you can get your own shark, the photo credits. And if you are interested in this kind of problems that we're facing, we're hiring at Bloomberg. I can go to this website to find out more. You can also reach out to me directly. So with that, thank you very much for your time. Hopefully that will help you in your journey on making chaos engineering more boring. And hopefully that was a very boring presentation. Take care, guys. Cheers.